with this one, what we're going to do is we're actually going to find the mean of a population. Now, the population's only 4. Are we right? The population's only 4. So it's not a large population. The sample's not actually going to be as accurate as it would if you were dealing with a large population. But we've only got this because we want to find out whether all of the samples that we can take are going to be even close to what the mean is of the population. So what you've got is a group of 4 people with their average heights. First thing you're going to do is calculate the mean height of the 4 boys. Then you're going to take the samples of 2. List all the possible samples of 2 that can be selected. You're then going to calculate the mean of each possible sample of 2. And you're then going to calculate the mean of all the samples. Okay? So there's 4 bits to do there. First off, do the mean. You got 30 seconds. Go. All right, should have got the mean by now. 181. Just add them all up, divided by 4 gives you 181. Question B says a sample of 2 from the 4 is to be chosen. List all the possible samples. Okay, start listing them for me. What are they? Let's go Aiden and Jake. What's another group? Excellent. It's an unordered selection. It doesn't matter whether you've got Aiden and Jake and Aiden. They are the same group. Okay, so it's an unordered selection, which means there's only 6. Everyone happy with that? Okay. Part C. You've actually got to find the mean of each of them. So we've got Aiden and Jake, Aiden Isaac, Aiden Chaz, Jake Isaac, Jake Chaz, Isaac Chaz. Go. 193 plus 187. And I'm just going to write it like that so that I've got space because I'm only allowing myself one line. 193, 193, 187, 187, 178 plus 178 plus 166 plus 178 plus 166. So now you go through and solve them. 187 equals 190. 178 193 plus 166. Delete. Now you can actually do that as long as you put it in brackets. You can do the whole thing in one go. Or you can actually do it as a fraction if you want. Still give you the same thing. The only trouble is that'll give you an answer as a fraction if it's got a decimal. So you got to press your button. It's divided by 2. It's just the slash, the oblique. Okay, I'm up to my last one. That's 72. Okay. So that's the 6 of them. Everyone happy with that? Just have a look at them in comparison to the mean that we found, the population mean. There's a couple that are reasonably close. There's a couple that are a fair way out. That's fair enough. You'd get that with means. Kirby, you done the last part? Find the mean of each answer in, find the mean of each pair in part C. Yes. Add them all together and divide it by 6. So you go 190 plus 185.5 plus 179.5 plus 182.5 plus 176.5 plus 172. Plus. Did you? What does that show you? Because if you have a look, the mean of the population was 181. They are both the same. What it shows you, well, should they? We didn't change it, but we didn't use the population. We used the mean of those samples. We took all those different samples, the 2 possibilities, like we took 2 people out of the 4 and used them as a sample. We took all those possible 2s, so 6 different possibilities. We added them up and found the mean of those samples. And what did we find when we found the average of those samples? It's exactly the same as the population sample. Does that make sense? What does it tell us? It actually says it down here. But this will happen all the time. If you take the mean of all possible samples, the mean of all possible samples will be the same as the mean of the entire population, which is why sampling works. If you do a correct sample, and if you did every possible version of that correct sample and found the average of them, it would be the average of the entire population. Okay? Now, you're not obviously going to do that because, well, then you might as well just do the whole population. But it does demonstrate that a repeated sample, if you keep doing that sample repeatedly with the same parameters and it's a good sample, then eventually you'll get very, very close to the actual population of the mean. The mean of the population. Population of the mean. That's good. Well done.